Welcome to the Starculus version of Exam Prep for the Algebra 1 end of course exam based on the 2021 released questions. Here we are on page 10 of the 2021 released exam, which includes questions 3 and 4. Question 3. The values in the table represent a linear relationship between x and y. We are given a table of values for x and y and asked, what is the rate of change of y with respect to x? Arg, so much vocabulary. Let's start with linear relationship. It simply means the table of values that we're given, if we plot them on a graph, they will create a line. So when we look at the graph, we'll see a straight line. And it could be sloped up, it could be sloped down. Rate of change simply means the slope. And when we find the slope of a line, it's just one value. It's the difference in the y's divided by the difference in the x's. But this says rate of change of y with respect to x. That simply means that x is the independent variable and y is dependent on that. So when we calculate the slope, it means that y is in the numerator and x is in the denominator. Since we are finding the rate of change or the slope of this linear relationship, all we have to do is grab 2 points, the easiest ones, and find the slope between those 2 points. I think the easiest point to use is -1, -17. And then to avoid using really large values, making some mistakes, let's just use the point to the left of that, -2.5, -32. So we have y2 minus y1, -17 minus -32, and I would use parentheses around that -32. In the denominator, we have x2 minus x1, -1 minus -2.5, again, parentheses. The negatives in the numerator and the denominator become positive. Negative means positive. And -17 plus 32 is 15. In the denominator, we have 1.5. Now I guess we need to divide 15 by 1.5. That means how many 1.5s are there in 15? What do we have to multiply 1.5 by to get to 15? And that is 10. Answer choice A. While getting the correct answer in this question is nice and helpful and makes us feel good, the big idea of this question is you need to know that a linear relationship between two variables yields just one slope. And the way that you find slope or rate of change is you subtract the y's, subtract the x's, and divide, such that the y's are in the numerator and the x's are in the denominator. Now let's spend a few minutes checking out question 4. Given g of x equals x squared minus 6x minus 16, which statement is true? First of all, this equation is written in function notation. We could simply replace g of x with y. So we have y equals x squared minus 6x minus 16. This is considered a quadratic equation or a quadratic function. And it happens to be an equation that we can factor. I don't know that just because I'm a math teacher, but because I looked at the answers. So look at the answers with me. They include zeros, and they also include binomials, like x plus 8, x plus 2, x minus 2, and so on. So let's see if we could factor g of x into 2 binomials. We're looking for 2 expressions that when you multiply them together, they get x squared minus 6x minus 16. The first term must multiply to x squared, so it must be x times x. The other term must multiply to -16, and notice the answers give us the clues. So 8 and -2, or -8 and +2. We're going to use the trial and error method. Let's just plug in x plus 8 and x minus 2, and then we can multiply the outer terms and the inner terms. The outer terms multiplied together give us -2x, and the inner terms multiplied together give us +8x. When we add those together, 8x and -2x, we get +6x. That's not correct. We're looking for -6x. All we got to do is switch the signs. So let's do x minus 8 times x plus 2. When you multiply the outer terms, you get +2x. When you multiply the inner terms, you get -8x. Aha! -8x plus 2x is -6x. Notice that answer choice H is correct based on the factorization, the 2 binomials that are included there. If we were to set each of those binomials equal to 0, x plus 2 equals 0, then x would be -2. X minus 8 equal to 0, we get x equals +8. There you go. That creates the connection between the zeros and those binomial factors.